Alright, so today we're working with only absolute value equations. So an absolute value equation follows this idea. If I have the absolute value of an expression equal to a number. Alright, so again, B is simply a number, and A is an expression. Then our solution, or our two solutions, because anytime you have an absolute value, you have two of them, is simply the expression equals the positive of the number, and the expression equals the negative of the number. We're going to split it up into two. Always do two in absolute value. However, there's one special little rule I need you to remember before we get started. I'm going to put a little star there. Before you can write two equations, the absolute value must be by itself. All right. Okay, so before we can split it into these two equations, the absolute value has to be by itself. That's key. All right. So here is example number one, starting off really, really easy. If I have the absolute value of, say, 2x is equal to 14. And? Ooh, yeah, exactly. Yes. So, is the absolute value by itself? It is. So we set our two equations up. The first one, we drop these absolute values. We have 2x equals 14. The second equation is we drop those absolute values and set it equal to negative 14. Now we have to solve them both. In this one, we divide both sides by 2, and x equals 7. In this one, we divide both sides by 2, and x equals negative 7. So if we were to take those answers and plug them back in, if I plug 7 in here, I get 14. The absolute value of 14 is 14. If I take negative 7 and plug it back in, I get negative 14. The absolute value of negative 14 is positive 14. Absolute value is always positive, right?
Yes, ma'am.
Okay. So we're clear on what we're doing? Okay, let's try example number 2. Is what it is. Example number 2, we have the absolute value of 2x minus 4 is equal to 10. So my first question for you is the absolute value by itself? It is. The absolute value is by itself. So we can split it into two equations. The first one is the 2x minus 4 equals positive 10. So all I did was drop the absolute value. The second equation is 2x minus 4 equals negative 10. So now I have two little bit equations to solve, right? All right, so here I add 4 to both sides, and I get 2x equals 14. So x equals 7. And the other one, I add 4 to both sides, I get 2x equals negative 6. So x equals negative 3. Very good. So fix it. Okay. So a couple things I want to point out. You are going to need to test it all the time. Right? All the time. The reason being is you're going to come across a few today. They're what we call extraneous solutions. So what we do first is we plug 7 in here. 2 times 7 is 14, minus 4 is 10. The absolute value of 10 is 10. That works. This one, if I plug negative 3 in here, 2 times negative 3 is negative 6, minus 4 is negative 10, absolute value is 10. So both of these work. However, you do have a couple problems today where they don't work. Those are called extraneous solutions. That's exactly where we were going next, okay? So, again, another little start here. Check. Solutions. To see if extraneous, E-X-T-R-A-N-E-O-U-S. What that means is that algebraically it works, but if you plug it back in, it doesn't. Okay? All right. We doing okay? Everybody good? Yeah. All right, here's example number 3. Oops. I guess I better put example word first, huh? Yeah. Yeah, I can move that. Just a minute. Oh, maybe I can move it. Back to right there. Okay. You're welcome. All right, so here is example number 3. So this time, we have the absolute value of 2x minus 4. I seem to like that expression today. 2x minus 4 plus 1 is equal to 7. Let me fix my 4 here. I know, I saw. All right, so my first question for you is this absolute value by itself? It is not by itself. How can I get it by itself? Yeah, so we're going to start by subtracting 1 from both sides. So we have the absolute value of 2x minus 4 is equal to 6. Now is the absolute value by itself. So we can set up our 2 equations. The first one, 2x minus 4 equals 6. The second one, 2x minus 4 equals negative 6. Now we solve them. Careful. Oh. Yeah, so if I add 4 to both sides here, I get 2x equals 10. Yep, so x equals 5. Yep, so if we add 4 here, we get 2x equals negative 2, so x equals, when I divide, what do we get? Negative 1. Okay, so, they both work? So let's plug in 5 first. We get 10 minus 4. 10 minus 4 is 6. Absolute value is 6. Plus 1 is 7. That works. The other one, if I plug in negative 1, I get negative 2 plus negative 4 is negative 6. Absolute value is 6 plus 1 is 7. That works. Okay, so they both work in this case. How about this one, example number 4? What's wrong? Okay, no, that's fine. Example number 4. I'm going to make it even tougher. I have 3 times the absolute value of 4x plus 1. Just a minute. Minus 2 equals 7. All right. Is that absolute value by itself? No. So, no. No. We're going to cover that. First thing we need to do to get this absolute value by itself is to add 2 to the other side, right? So add 2 to both sides. We get 3 times the absolute value of 4x plus 1 equals 9. Now tell me, what is that 3 doing to that absolute value? So how do we get rid of it? We cannot distribute. I want you to think of those bars as like bars to a jail cell. You cannot get in and you cannot get out. Okay? Are you going to listen? You just told me, I know. You just told me that you multiply when they're next to each other. To get rid of it, we're going to divide. So we're going to divide this side by 3 and this side by 3. So on this side, we're left with the absolute value of 4x plus 1 equals, and on this side we have 3.
Oh, wait a minute, I remember this.
Now we can write our two equations. The first equation is 4x plus 1 equals 3. The second equation is 4x plus 1 equals negative 3.
So for the second one, I need to subtract 1.
Uh-huh.
4x is negative 4.
Good. So what does x equal?
X equals 1. Negative.
Negative 1, okay. Over here, if I subtract 1 from both sides, I get 4x equals 2. So x equals 1/2, right? Okay. And again, if you test them, in this case, they both work. So I want to keep going. All right? Are we good? Do we have questions at all so far? So let me throw this up there then. I got to move it up a little bit. All right? We've got to make it just a little bit tougher. You can see why I didn't want to do this whole lesson in one day, right? Yeah. Okay. So here is example number 5.
I already don't know how to do it.
You haven't even seen it.
Don't know how to do it.
All right, this time I have the absolute value of x plus 3 is equal to 2x minus 1.
Oh, that's not good.
All right, so first question, is the absolute value by itself? Yes, okay. So that means that I can drop my absolute value. My first equation is x plus 3 equals 2x minus 1. What do you think it is, CJ?
It is x plus 3
Uh-huh.
equals negative 2x plus 1.
Very good. X plus 3 equals the opposite, or negative, of 2x minus 1. TJ is right. We just switched it all, right?
It's the first time anybody's ever said that. I swear.
Yep, negative in parentheses, and we're going to end up distributing, Irene, okay? All right, so let's do this side first. As you put it down, you can just change them all, yes. Yes. I just wanted to have it in your notes so that you know why you changed it. Okay? All right, everybody still good? So let's solve both of them. No, go ahead, Colton. We can. That's what we were just talking about. I just wanted it, just a minute. I just wanted it in your notes, Colton, so if you look back, you knew why you made it 2x plus 1. This is why. It's the opposite, just like we did for everything else, okay? I wanted you to have that to know why we did something. So here I'm going to subtract 2x to the side. I get negative x plus 3 equals negative 1. Whoops, that's negative 1. Then I go ahead and subtract 3 to that side. I get negative x equals negative 4. So x equals positive 4. That's one of our solutions. Over here, x plus 3 equals negative 2x plus 1. Right? So I'm going to move my x to this side. I get 3x plus 3 equals 1. Subtracting 3 to that side, I get 3x equals negative 2. X equals negative 2/3. Now, when you get to these problems in your homework, it actually tells you at the top, check for extraneous solutions. Okay? So, let's do that. Right here, I'm going to take my 4 and plug it in. So on this side, I get what number? I get 7. Over here, if I plug 4 in, I get 8 minus 1, I get 7. So this works. Let's plug this one in. If I put negative 2/3 in here, I get 2 1/3, we'll just say, right? Everybody agree with that? Over here, however, if I put negative 2/3 in, I get negative 4/3 minus 1. So I end up with a negative number. Can an absolute value ever equal a negative number? Nope. So which one of these is an extraneous solution this time? Yeah, so we're just going to go ahead and cross that one out. So you have to find them both, but then you got to decide which one didn't work. Okay? All right, do we need another example like this? You guys are okay switching it all opposite? If you're good, I only have one more example to go. I gotta do this one, Colton. I'm sorry. All right, here's my last example then. If you guys think you're good. Here's example 6. Absolute value of 3x minus 7 plus 9 equals 2. What do we have to do first? Very good. We have to subtract 9 to the other side. So you have the absolute value of 3x minus 7 equals negative 7. Now what? Ooh. So here's why I wanted to do this problem. Can an absolute value ever equal negative 7? It can't, can it? So this becomes no solution. No solution. Okay, so just a minute. There is absolutely no number, think about it this way, Irene. There's absolutely no number I can come up with that I can put in here that's going to give me an answer of negative 7. Because anything I put in here, exactly, okay? But that doesn't give us a solution. If I did that, it would change it. I agree. Okay? If I put x equals 0 in here? No, I get a negative 7. What's the absolute value of negative 7? Positive 7. Does positive 7 equal negative 7?
No, I was saying if you had a negative on the outside.
Oh, okay. Yep. I prefer no solution, but both are correct, technically. Okay? No questions? So, your assignment today, again, listen up, is 10 to 24 off. The reason I'm including some odds are because the odds are in the back. It's important that you can check and make sure you're doing it right. You want that option so that you are making sure you're checking on your own learning, right? You're making sure you're understanding it. So if you're not getting those answers for the odds that are in the back, you know, okay, we got a problem, and I need to ask Mrs. Shoemaker tomorrow, okay? All right, good deal.